Okay, so Meta just dropped Llama 4, and the open source AI world has been buzzing. After another company, DeepSeek, kinda stole the spotlight for a minute, everyone was waiting for Meta's comeback. So I spent the weekend playing detective, trying to piece together what exactly makes this new model tick. All right, let's dive in. The very first thing you need to wrap your head around is this number: 10 million. That is the token context window for Llama 4. We're talking about shoving 15,000 pages of text, an entire code base, or hours and hours of video scripts into a single prompt. This is just, it's a completely different scale from anything we've seen before. And a number that big immediately brings up some huge questions. Like, what in the world does native multimodality actually mean? How do they possibly crack the code to get a 10 million token context window? And probably the most important question, does it actually perform as well as the hype suggests? That's exactly what we're going to figure out. So first things first, let's get properly introduced to the Llama 4 family. This is Meta's ambitious new lineup, and it's designed to go toe-to-toe with the biggest names in the game. It comes in three main flavors. You've got Behemoth, and yeah, it's a behemoth, a staggering 2 trillion parameters. This is their shot at models like GPT-4.5. Then there's Scout at 109 billion parameters, which is supposedly the one you can run locally, if you have a ridiculously powerful GPU just lying around. And sitting right in the sweet spot is Maverick with 400 billion parameters. But hang on a second, 2 trillion parameters? How is that even usable? Well, the secret sauce is a technique called mixture of experts, or MOE for short. The idea is pretty simple, actually. The model is like a giant team of specialists, but you don't need the whole team for every single question. So an MOE model only activates a small group of the right experts for the job. In Maverick's case, it uses less than 5% of its total brain power for any given task. This saves an absolutely massive amount of compute and memory and makes these gigantic models actually practical. All right, let's tackle that first big buzzword that Meta's been touting: native multimodality. You hear this term thrown around all the time, so let's break down what it really means for Llama 4. To really get why Llama 4 is a big deal here, you have to look at how Llama 3 worked. Its approach was kind of bolted on. You had the main text model, and then they attached separate pieces for images, and trained these little adapters to get them to talk to each other. It worked, but it was clunky. Llama 4, on the other hand, uses what's called early fusion. From the very beginning, it's one single unified model designed to handle everything together. So how does this unified thing work for an image? Well, it starts by chopping the image into little patches. Each patch gets turned into a string of numbers. But here's the really clever part. The model has this thing called a codebook. Think of it like a dictionary, but instead of words, it's full of visual puzzle pieces. It looks at the numbers for an image patch, finds the closest matching puzzle piece in its dictionary, and gives it a token ID, the exact same kind of ID that a word gets. And just like that, text and images are now speaking the same language. And this is the real game changer. Because everything, text, images, you name it, is just a token, you can train the model on much richer, more complex data. You can feed it a document with text and pictures all mixed together in the correct order. Or you could feed it video frames and audio at the same time. The model gets to learn from the world in a way that's much more holistic. And as the researchers say, a lot more like how our own brains work. And now, for the main event, that absolutely mind-blowing 10 million token context window. Pulling this off is an incredible technical achievement. So let's take a look at the secret sauce. Okay, so the biggest enemy of long context has always been what's known as the O(n)² problem. In a standard AI model, every single token has to pay attention to every other token. The math gets out of control fast. With 1 million tokens, that's 1 trillion calculations. If you scale that up to 10 million tokens, you're looking at 100 trillion calculations for just one single layer of the model. It's just computationally impossible. So the solution they're almost certainly using is a technique called ring attention. Instead of that all-on-all approach, the input gets broken down into chunks. Attention is only calculated within each chunk, which is much more manageable. Then, as you move up through the model's layers, information gets passed from one chunk to the next, kind of like a baton in a relay race. It's a really smart way to get around that insane scaling problem. But solving the compute problem is only half the battle. There's another tricky puzzle: length generalization. Llama 4 was only trained on up to 256,000 tokens, so how does it handle 10 million without getting lost? Well, it comes down to how it tracks a token's position. Llama 1 used a method called rope, which kind of gives each word's data a specific spin based on its position. Llama 2 slowed that spin down to help over longer distances. Now, Llama 4 uses something called iRope, which is pretty ingenious. It alternates between layers that use rope to know the exact position and layers that have no idea about position. This weird trade-off gives it the best of both worlds, making it accurate at both short and long ranges. So we have this revolutionary architecture in a truly massive context window. But the billion-dollar question is still hanging out there. How well does it actually perform? Let's see where the hype meets reality. Now, if you just go by Meta's official blog post, the story is pretty simple. Llama 4 is the new king of the hill. The charts show all three models, Behemoth, Maverick, and Scout, beating every major competitor on all the standard tests. Case closed, right? Well, not so fast. Once the model got into the hands of the community, people started running their own tests, and the results, they're surprising. On the ADER coding benchmark, which throws really hard programming challenges at the AI, Llama 4 Maverick scores just 15.6%. For comparison, the leader, Gemini 2.5 Pro, is up at nearly 73%. That's a massive gap. And that trend continues. On Simple Bench, a test that's full of gotcha questions with lots of distracting information to test reasoning, the story is similar. It'll ask things like, how many ice cubes are left in a frying pan after 3 minutes? Humans get that right about 84% of the time. The top AI model is at 51%, and Maverick, it's way down at 27.7%. But surely, it has to crush the long context tasks, right? That's its main selling point. Unfortunately, the community benchmarks tell a different story. This test checks how well a model can understand long stories by asking about plot points and characters. On a 120,000 token task, Maverick scores a pretty modest 28.1%, while Gemini 2.5 Pro absolutely nails it with over 90%. These results really paint a complicated picture. The technology is clearly groundbreaking, but the performance just doesn't seem to be there yet across the board. And this leads to a much bigger conversation about the future of these enormous context windows. You know, the first thing everyone asks when they see a 10 million token context window is this. Is RAG finally dead? If you can just stuff all your documents right into the prompt, do you even need those complex retrieval augmented generation pipelines anymore? For now, the answer is a pretty firm no, and the reasons are important. Big companies with decades of internal documents aren't just going to cram all of that sensitive data into a single prompt for every single query. And plus, let's be honest, RAG itself is incredibly complicated and finicky to manage. So while we're all hoping for a more elegant solution, the reality is that we'll probably be using these hybrid approaches for a while. And that really brings us to our final question. Llama 4 is, without a doubt, an architectural marvel. The native multimodality, the tech that makes that huge context window possible, it's a huge step forward. But the real-world performance seems to be lagging behind the hype. So what is this? Is it a true breakthrough that just needs more refinement? Or is it a powerful lesson in the very difficult trade-offs between groundbreaking innovation and practical, reliable performance? I guess only time will tell.